Hello, dear students. This time I thought I'll make a video that's going to be helpful to a whole host of different students studying Algebra 1 and 2, Pre-Calculus, IB Maths, AA and AI, GCSE, IGCSE, and AS and A-level Maths. This is, of course, the topic of function transformations. I'm sure that many of you might have let out a subtle groan when I talk about this particular topic because it is rather difficult. I hope to make things a little easier with this particular video. Please watch till the very end. Um, I have broadly classified it into two parts. One is vertical stuff and the other is horizontal stuff. Now, vertical stuff basically acts on the y coordinates because the vertical axis is the y axis. So when I talk about vertical stuff, it is, only acting on the y coordinate of a particular point. So under vertical stuff, the first transformation is called a vertical translation or a vertical shift. Now, this vertical shift could be up or down, right? And it is given by the general rule f of x plus k. So what you're doing is the original function f of x, whatever the equation is simply being added or subtracted by k. Of course, if k is positive, it gets added. If k is negative, then it gets subtracted. So what this effect is basically that all the y coordinates simply get added or subtracted by the value of k. So if you look at this particular graph, right? And if this particular graph needs to be shifted up, then what happens is all these points get shifted up by a certain amount. So you can see that in each case, right, the x coordinates stay the same, but it's only the y coordinates that get shifted up, right? So this is what a vertical translation is going to look like. So if you have, let's say, f of x plus 3, it means it's going to get shifted 3 units up. If you have f of x minus 2, it's going to get shifted 2 units down. So essentially, a graph that looks like this, let's say it's got a few points, 0, 0, let's say it's got a point 2, comma 1, and let's say this point is negative 3, comma 2. So I've just taken a random graph and I've marked 3 different points on this graph. If I want to graph f of x plus 3, then you know that all these points simply get shifted by 3 units up. So this point, negative 3 and 2, when you shift it up by 3 units, becomes negative 3 and 5 because it's just that the y coordinate alone gets added by 3 because you're moving it up by 3. And similarly, the point 0, comma 0 simply becomes the point 0, comma 3, and the point 2, comma 1 becomes 2, comma 4. So on the same graph, 0, comma 3 may look here, may appear right here, and negative 3, comma 2 may be there, and 2, comma 1 is approximately there. So the new graph is going to look like this. And this is basically your graph f of x plus 3 if the original graph f of x is drawn over here. All right. And in much the same way, if you want to graph f of x minus 2, then this black graph f of x gets shifted down by 2 units. And in that case, all of the y coordinates get subtracted by 2 units. All right, so this is the first vertical transformation. It's called vertical translation or vertical shift. Now let's move on to the next one. This is called a vertical stretch or shrink. It's very likely that the word stretch and shrink is applied for American math, that is Algebra 1 and 2 and pre-calculus. And for the IB math, it's quite likely they may use the word stretch or dilation. And for GCSE, IGCSE, and AS and A level, it is likely that they would use the word dilation itself. All right, so what happens in this case? Well, again, if you recall, I mentioned to you that something happens to the entire function as a whole. So the function is given by a certain equation. If that equation gets multiplied by some particular number, A, in that case, it is basically a vertical stretch. Now, if A is greater than 1, then that's a vertical stretch. And if A lies between 0 and 1, that's going to be called a vertical shrink. So how does this work? Well, again, your original graph was f of x, so the original y values simply get multiplied by A to get the new y values for this particular graph. So let's say that f of x had some points, 0, comma 2. Let's take the same points that we have here, 0, comma 0, 2, comma 1, and negative 3, comma 2. So 0, comma 0, and then 2, comma 1, and negative 3, comma 2. So if you want to, let's say, vertically stretch this by a factor of 2, then that simply is written as 2 times f of x. Because you're vertically stretching it, it means that the y coordinates change. In this case, the y coordinates get multiplied by the number 2. So 0, comma 0, when you take 0, comma 0 and times the y coordinate by 2, it remains 0, comma 0. And if you take 2, comma 1 and times the y coordinate by 2, it becomes the point 2, comma 2. And negative 3, comma 2 will become negative 3, comma 4. Now, how does this look on a graph? Well, let's take a look. 0, comma 0 is right here. And your original point 2, comma 1 is here. And negative 3, comma 2 is over there. So let's say the graph looks something like this. Now, we don't know what kind of graph this is. It doesn't matter what it is either, just a random graph. This was your original graph f of x. So if you do 2 times f of x, right, all your y's get doubled. So here the point stays the same, 0, comma 0. 2, comma 1 becomes the point 2, comma 2, and negative 3, comma 2 becomes negative 3, comma 4. So the new graph looks a lot steeper, and it looks like this. So this is how you can graph 2 times f of x. All the y coordinates get doubled or get multiplied by 2, which therefore produces an effect that the original function kind of gets vertically stretched out. Imagine taking a rubber band and stretching it vertically up and down, with your two fingers. So that's what's happening here. And this is how you deal with a vertical stretch. Now, if you have a vertical shrink, right, essentially all the y coordinates get divided by something, right? As an example, for vertical shrink also, you will apply the same formula, but the a value lies between 0 and 1. All right, that's the rule for vertical shrink. So what happens in this case is, let's say that you have the same function f of x, and let's say you've got these same 3 points, right? Let's take these same 3 points. And let's say that you want to vertically shrink it, vertical shrink by a factor of 1/3, or let's say by a factor of 1/4. So what happens in this case is that all the y coordinates get multiplied by a quarter. So it becomes 1/4 f of x, which can also be thought of as f of x divided by 4. So your new y coordinates will simply get divided by 4. So 0, comma 0 remains 0, comma 0. 2, comma 1 becomes 2, comma 1/4. And negative 3, comma 2 in the original f of x function becomes negative 3, comma 2 divided by 4, or 1/2. Now, how does this look? Well, you've got 0, comma 0, and you've got the original point 2, comma 1, which is here, and you've got negative 3, comma 2. Now, these are the points on the old function f of x, as in the original function f of x. I'm just giving a simple example of some 3 random points on f of x. Now, if you want to graph f of x divided by 4, all the y coordinates get divided by 4. So these are your points that will lie on the graph f of x divided by 4. So this 0, comma 0, and then 2, comma quarter will be approximately here. Negative 3, comma half will be approximately there. So you can see that the graph is approximately going to look like this. So you can see that it has kind of gotten vertically shrunk, as in all the y coordinates have gotten lower, you know? That is how a vertical shrink looks. Okay, so this takes care of two different transformations. One was vertical translation up and down, in which the graph simply moves up or down. And another is vertical stretch or shrink, right? And now we have another one, which is your vertical reflection, vertical reflection, which is also called reflection about x-axis. So how does this look? Well, essentially in this case, you're simply going to be taking the function and just plopping a negative in front of it. This is how it works. Now, let's take an example. Let's say we've got a point 2 comma 1. Okay, this is the point 2 comma 1. Let's say you're reflected about the x-axis. Wouldn't that point now become 2 comma negative 1? So essentially, reflecting it about the x-axis simply results in the y coordinate changing sign. Okay? And it is given by the rule negative f of x. So let's say, for example, they've got the same exact graph for f of x with the same 3 points, 0, 0, 2, 1, and negative 3, 2. So I'm going to go ahead and draw this again. I mean, essentially, let's also find negative f of x. Negative f of x is a reflection about the x-axis, which means all the y's will change sign. So 0, 0 remains 0, 0. 2, 1 becomes 2 and negative 1. And negative 3, 2 becomes negative 3 and negative 2. So let's draw both the original function in black, 0, 0, and then you have 2 comma 1, and you've got negative 3 comma 2. So the graph kind of looks like this. Now, if you want to reflect it about the x-axis, we do negative f of x, whose points have already been obtained here. 0 comma 0 stays the same. 2 comma negative 1 is down here, and negative 3 and negative 2 is there. So you can already see that this is literally a reflection about the x-axis, another word for which is the vertical reflection. All right, guys, so these are the three different transformations, three different vertical transformations. Stay tuned for the next video, which will be on horizontal transformations, which is much tougher. I will see you on the next one. Please comment, share, and subscribe if you found this helpful. I'll be putting this both on my channel and on LinkedIn. Please do give it a watch, and please um, let me know if there is some things that you'd like changed in the video, and I will see you on the next one. The next video is going to deal with horizontal transformations. Thank you for watching, guys, and have a good one.